Good morning, everybody. I hope that we're having a great day and a great week so far. Today's video is going to be all about factoring by the greatest common factor, the process of how to do that, what that actually means. We'll find out here pretty soon. All right, so let's get right to the video.
Today's video is going to be all about the greatest common factor. And by the end of this video, I hope that you're able to rewrite an expression as the product of the greatest common factor and the remaining polynomial. Let's start with some vocabulary, okay? You can work backwards to express a polynomial as the product of polynomials backwards. And in fact, that's really called factoring. And factoring is the process, or it's rewriting an expression as the product of polynomials. It's almost like you are undoing distribution or undistributing. It's really like you were working backwards, like was mentioned. And in fact, the last thing, the greatest common factor, which in this case I'm just going to write as the GCF, is the largest quantity that is a factor of all the integers or polynomials involved. So let's start off with some greatest common factor practice. Find the greatest common factor of each list of numbers. So if I start with 12 and 8, what I really need to do here is think about what numbers are factors of 12 and 8. Well, 12 can be made up of 1 and 12, 3 and 4, 6 and 2. Okay? And I also need to think about what factors make up 8. 1 and 8, 2 and 4. I see here that they both share a 4 as a factor, and in fact, that is the greatest factor that they share. So in that case, the greatest common factor between 12 and 8 is 4. B is a little bit tricky with 7 and 20. 7 is a prime number. So in fact, since 7 is a prime number, meaning it can only be made up of itself and 1, the greatest common factor between 7 and 20 has to be 1. If I were to look at C, 4, 12, and 26, I know that 4 and 12, their greatest common factor would be 4, but 26 cannot be made just by using 4s. In fact, I need to think 26 is an even number, 12 is an even number, 4 is an even number. So in fact, their only greatest common factor that they are going to have is 2. And that's not always the case. Just in this particular example, 26 is not able to be made by 4. So in fact, the next greatest common multiple or common factor that they had was 2. And this same thing works with exponents as well. Find the greatest common factor of each list of monomials. I need to think about, for part A, I have x to the third and x to the seventh. How can I make x to the third using, or how can I make x to the seventh using x to the third? Well, in this case, x to the third is made up of x times x times x, and x to the seventh is just 7 x's in a row. When I look at these factors, their greatest common factor is just 3 x's or x to the third. So in fact, I can just see here that the greatest common factor between two variables is really just going to be the lowest exponent that they have, okay? So for example, for part B, 6x to the fifth and 4x to the third, I know automatically that the greatest common factor they have with their variables is going to be x to the third. And now I need to find the greatest common factor between 6 and 4, and that's going to be 2. So my greatest common factor between 6x to the fifth and 4x to the third is 2x to the third. If I look at part C, they now throw in a y, but nothing really changes. So first off, my greatest common factor between 3 and 12 is going to be 3. My greatest common factor between x and x squared, remember, is just going to be the variable with the lowest exponent that it has, so it's x to the first power. And the same thing for y. The greatest common factor between y squared and y is just y. So my greatest common factor between those two monomials is 3xy. Let's try a couple of different examples here. So I need to find the greatest common factor between 15x squared and 100. Well, the greatest common factor between 15 and 100 is just going to be 5. So it's almost like what I'm doing now is 15x squared divided by 5. Well, 15 divided by 5 gives me 3, and I'm just left with x squared there. And 100 divided by 5 gives me 20. This is really where we start to see this undistributing. And in fact, we write this out as our greatest common factor times our remainder, because it really is like we are doing division based off of our greatest common factor. I'm going to jump down to C. I look for the greatest common factor between 3x squared and 6x. Well, I know for my integers 3 and x, the 3 and 6, my greatest common factor is going to be 3. And my greatest common factor between x squared and x, again, is just going to be my variable with the lowest exponent, so 3x. And now this is really like 3x squared divided by 3x. Well, 3 divided by 3 gives me 1, and x squared divided by x gives me x. And 6 divided by 3 gives me positive 2, and x divided by x gives me 1, or just cancels each other out. So in fact, my factored out form is going to be 3x times x plus 2, or 1x plus 2. Moving down to E, I first need to find my greatest common factor between 6, 9, and 12. That's actually going to be 3 again. And my greatest common factor between x to the third power, x squared, and x is just going to be x. And now this is where I go ahead and start dividing. So 6x to the third power divided by 3x is going to give me 2x squared as my remainder. Negative 9x squared divided by 3x is going to give me minus 3x. And 12x divided by 3x is going to leave me with 4. Last question for this page. I have 6 times the quantity x plus 2 minus y times the quantity x plus 2. This one looks a little bit different, but functions the same. I'm looking for my greatest common factor, what they share. They both share the binomial x plus 2. So in fact, I'm going to undistribute that part from this expression that we have. So my greatest common factor is x plus 2, and I'm left remaining with 6 minus y. So in fact, I can almost just pull these out and then leave what is there and combine those to make another binomial. We're going to do one more question together and then that'll be it. So I need to try to find the perimeter of this triangle, and I need to express that final answer in factored form. So this really works on my adding polynomials. So what I need to do here is I need to see, I have 6x cubed. X cubed is my highest term here. In fact, there are no other x cubes, so I know that I can write that first. Then I'm looking for any other terms that have an x squared, none of them do, so in fact I leave this as 12x squared. And finally, I see that I have a lot of just normal x's that I can combine. So 3x plus 4x gives me 7x, plus 11x gives me 18x. So this is my perimeter, but it's not my perimeter in factored form. So I need to go ahead and factor this now. So I need to find my greatest common factor between 6, 12, and 18, which is going to be 6. And then my greatest common factor between x cubed, x squared, and x is just going to be x. So now I need to go ahead and start doing division. So 6x cubed divided by 6x is just going to leave me with x squared. 12x squared divided by 6x is going to give me 2x. And 18x divided by 6x is just going to leave me with 3. And this is my answer in factored form. And those are all the questions that I have for you today. If you have any questions, feel free to leave a comment in the comment section down below, or you can message me on Schoology. I hope that you have a great rest of your week, and I look forward to seeing you next time.